Well, hello there. Today, we're going to take a look at a free response question that is on your page. It's what we're going to call 2020 BC1. Okay, this is a practice problem from the new topic that I've created. So here we go. 2020 BC1, we're given a piecewise function here of 3 line segments, a quarter circle, and then this graph of 32 over x squared. Now, remember, unlike those physics problems, if you have information, you're going to use it. And so we know that eventually this is 32 over x squared. This continues on, getting closer and closer to the x-axis, right? And so even though the problem specifically deals with -4 to 6, trust me, we're going to be dealing with that a little bit later. But let's see what we got here. Part A says, give me relative max and relative mins of f. And this is the graph of f prime. So this is a graph of f prime. We want the relative mins and maxes of f on the interval -4 to 6. Well, say it with me. Relative min occurs when f prime changes what? That's right, negative to positive. And that's happening at x equals 3. Right? Because f prime changes negative to positive. Now, what about a relative max? Well, let's see. We've got a relative max. Where? Say it with me. That's right. Where f prime changes positive to negative. And that's going to occur at x equals 1. Okay, pretty straightforward question there. Pretty happy. Let's go to part B. Part B says, find all values where f has a point of inflection. What does point of inflection do? Well, common mistake students make is to say point of inflection is where f double prime equals 0. But you're not going to make that mistake, are you? Because you know that points of inflection occur where f double prime changes sign. So where would the derivative of this change sign? We've got going down to up. So I'm going to say at x equals -2. Up to down, I'm going to say at x equals 0. Down to up, back at 2, and then back at 4. Now, why do all these occur? These are points of inflection because f double prime changes sign. Okay, that's what we're looking for. Don't avoid the common mistake. But those would be your points of inflection. Now, the trickiest one in this problem is part C. Part C says, write an expression for f that includes an integral. Use the expression to find the values of f of 1 and f of 3. Okay, I'm going to leave the curve up here. We're also given that f of 0 equals 5. Okay, so I'm going to erase parts A and B here, and then let's take a look at part C. Once we get the first part of part C correct, then we're home for part C and for part D. So here we go for C. What do we know? How can we get f? Well, let's go the integral. Now I know f of 0, so we'll go here to x, because it's asking me for f of x, right? So if I take the integral from 0 to f of f prime, from 0 to x of f prime of t dt, what will that give me? Integral of a derivative. That's right, it's going to give you f of x, isn't it? So this is going to be f of x minus f of 0. Oh, wait a minute. If I just solve that for f of x, I'm going to have an expression for f of x that includes an integral. Holy smokes, look at that. F of x equals f of 0 plus that integral. But what's f of 0? That's right, 5. 5 plus the integral 0 to x, f prime of t dt. And we're going to put a little box around that because that's going to bring us home now for the rest of part C and for part D. Okay, f of 1 and f of 3. Here we go. Are we ready? F of 1. That's going to be 5 plus the integral from 0 to 1. Oh, area of a triangle. Hey, knuckle dragger up there in geometry. What do you get the area of a triangle? Oh, 1/2 pH. That's right. So we're going to go 5 plus 1, and we're going to get 6. How about f of 3? That's going to be 5 plus the integral of 0 to 3. Hey, knuckle dragger, once again, 1/2 BH, 1/2 BH, but this one's negative, isn't it? That's right. So we've got 1, and that's going to be 2 times 2 times 1/2, so that's going to be -1. So 5 plus -1, and we'll get 4. And that's part C. Now for part D, on the interval -4 to 6, find the absolute min and the absolute max of f. Okay, anytime you see that word absolute, min or max, you know what you have to do. Say it with me. Candidate test. That's right, candidate test. Here we go. Let's go x, and let's go f of x. And you can do it with me, okay? So let's rock it out. What are my options? Well, -4. Now let's go back to part A. Where did those relative mins and maxes occur? Oh, that's right, 1 and 3. 1, 3, 6. Okay, now how are we going to get f for each of these? Just the same way we did right from this little box right here. And you can do this, plug and chug, using your help from your 9th graders upstairs, a little geometry, okay? -4 to 6. So here we go, all right? Now, 6 will be a little tricky. 6 the 9th graders can't help you on, but we'll get to that one in just a second. All right, so let's go -4. 5 plus the integral from 0 to -4. Well, from 0 to -4, that's going to be right to left, so that's going to be all of this negative area, isn't it? Right? And I already know that f of 1 is 6. So I'm going to be able to throw that out for a max. But what about a min? That's going to be a pretty good choice for a min. Let's go ahead and figure it out. Okay, so I've got the triangle here. So that goes up 4, and it's pretty clear on your graph that that's also 4. So 1/2 base times height. This is going to be 4 times 2, 8, so that'll be 4 underneath here. This is a quarter of a circle, so that's going to be a circle with radius 2. So this is going to be pi. So when we plug this in, we're going to get 5 plus the opposite of 4 plus pi. So 5 plus the opposite of 4 plus pi. 5 minus 4 is 1 minus pi, 1 minus pi. Okay, there's the minimum for -4. I hope you can see that. Let's go to 1. Oh, wait a minute. We've already done 1. That's 6. Let's go to 5. Oh, we've already done that. That's 4. How about 6? Okay. So 6 is going to be 5 plus the integral from 0 to 6 of this, right? So we want to get that area from 0 to 6. So what do? All right, well, let's rock it out. So we've got 1 here. I've got -1 down here, and I've got -1 here. I've got another 1 here. Well, look what happens there. All of that goes away. So really, I can change this lower limit to a 4. Because look up here. 1, -1, -1, 1. Those all go away. They cancel each other out. So how do we do the integral from 4 to 6 of 32 over x squared dx? Well, we can do that because we know how to integrate x to the -2. And don't you dare say natural log. That only goes with x -1. So here we go. I'm going to write this down here. So this is 5 plus. Now, 32x -2. Let's integrate that. That's 32x -1 over -1, right? So that's -32 over x evaluated from 4 to 6. So that's going to be 5 minus, I'm going to put this in parentheses now, 32 over 6 minus 32 over 4. Okay, so this should come out pretty nicely. Let's see. 5 minus -8, that's 13. 13 minus 32 over 6. 13 is 78 over 6. 78 over 6 minus 32 over 6 is 46 over 6, which is 23 over 3. You're exactly right. So we'll call this 23/3. Now, question. Absolute max, absolute min. Well, I'm looking at my absolute min right there of 1 minus pi. So here's your absolute min, 1 minus pi, and it says find the absolute minimum values of f. So let's see, can I go over here? Absolute min of f is 1 minus pi. How about the absolute max? Let's see, I've got 6, I've got 4, I've got 23/3. Absolute max of f is 23/3. I hope you can all see that down there. That's part B. All right? And that's how this works out. Let's bring it home with part E. This is our improper integral, and you know how to do this. We're going to take the integral from 4 to infinity of 32 over x squared dx. We just integrated 32 over x squared, so I know that's -32 over x evaluated from 4 to b, where b approaches infinity. Now, if this were a real calculus class, of course, you would rewrite this integral as the limit as b approaches infinity from 4 to b of 32 over x squared dx, right? But you can go right to here. Now, what does that become? That's -32 over b minus -32 over 4. How about as b goes to infinity? That's 0 plus 8, or 8. And that is the limit for the area of the region bounded by the x-axis, x equals 4, and the portion to the right of x equals 4. That's it. This is the first problem of our free response practice. And until next time, have a great day. We're going to let Susan Tedeschi bring us home because yesterday, one of my favorite songwriters passed away, John Prine. Here's a cover of Angel from Montgomery.
Unless lightning was desire, this old house would have burned down a long time ago. Now make me an angel that flies from Montgomery. Make me a poster of a whole rodeo. Just give me one thing, Lord, that I can hold on to. To believe in this living is just a long ways to go. Oh, yeah.